This podcast was created to educate listeners on the experiences of diverse individuals. However, all opinions expressed by the host or guests do not reflect the overall standing of Tarleton Radio or Tarleton State University.
Hello everyone, welcome to Making Space, the Diversity Dialogue, and I'm your host, Cole. This is a bi-weekly podcast where together we'll have questions answered about socially sensitive topics while learning how to create lasting relationships with diverse people. Now this episode's topic is very sensitive. At the time of recording, we are experiencing a pandemic. The outbreak is of a novel coronavirus, also known as COVID-19, has put personal health care at the forefront of our minds. There have been a lot of questions raised about viruses, infections, herd immunity, and much more, so that's what we're going to talk about this episode. And here to assist me are two special guest experts. That's Dustin Edwards and his research student, Faith Cox. Now, Dr. Dustin Edwards is an assistant professor with Tarleton State University's Department of Biological Sciences. He received his doctorate in the biomedical sciences at Baylor College of Medicine and did his postdoctoral fellowship with the National Cancer Institute. Now, Faith, do you want to introduce yourself a little bit as well?
Yes, I'm here with Faith Cox, who is an intern for our virus discovery program here at Tarleton State University, and she has been a virology research assistant for the last 2 years.
All right, very nice. I think we're going to go ahead and start with our vocabulary. So we can discuss this. I'm just going to give the base definition for the vocabulary, and then you guys can branch off from there. So the first one on our list is herd immunity. And what that is, if you look it up on the internet, it's the resistance to the spread of a contagious disease within a population that results in a sufficiently high enough population of immune individuals. That's kind of a crazy definition. Do you guys have maybe a better one?
Well, I like to try to think of it as a game of tag. So if you had a group of people, and let's suppose the person who was infected was wearing a red shirt, and all the uninfected people would be wearing a white shirt. And so if a person that had the red shirt touched somebody with the white shirt, it would turn red. And so that would be a transfer of the infection. Now with herd immunity, if you had people who were immune to the virus, they had antibodies to it, they could be wearing a blue shirt. And so if you have a whole group full of people wearing blue shirts, and then a few people wearing white shirts who are uninfected, it'd be very hard for the person wearing that red shirt to be able to tag that uninfected person.
Okay, that's a very nice way to look at it. It's very visual, and you can definitely see that. Very nice, thank you. Now, our next couple words are going to be CDC. Not a lot of people know what that stands for. It's actually an organization called the Center of Disease Control, and that's run by the government.
And prevention.
Sorry, I missed that part. Thank you. And that is basically a lot of public health individuals, epidemiologists, virusologists, I think. I'm not sure how to say that. And the WHO is the next one, which is the World Health Organization. Now, that's a global organization. And then our next word is infection. That is the invasion and multiplication of microorganisms such as bacteria, viruses, and parasites that are not normally present within the body system. And that's what we're experiencing right now with illness and sicknesses. That's what infection is. Now, your immune system, that is a bodily system that protects the body from foreign substances, cells, tissues, and then that produces an immune response. Now, that immune response is usually like fever and other things like that, right, Dr. Edwards?
Yeah, so an immune response would include a fever and things that you would associate with inflammation. But an immune response can also be antibodies. And so once a pathogen has been detected by some of your immune cells, they can display them to other immune cells that will begin to produce antibodies that will give you longer lasting protection against that pathogen.
So antibodies work by acting as a tag of sorts. So they kind of can flag a pathogen to either be taken in by the immune cells so they can't go anywhere else, or there are these receptors on the pathogens that have to interact with our cells to cause harm, but they clog the receptor so they're no longer able to cause harm.
Okay, wow. And now I've heard like white blood cells are like something that helps the immune response. Is that true?
Yeah, when you look at blood components, we'll often think of things like as red blood cells, which are, when you cut yourself, it's red that comes out. And then there's white blood cells, and the white blood cells are going to be your immune cells. And so you might hear on TV or on the internet about T cells and B cells and macrophages. So those are all of your white blood cells.
Okay, all right. Thank you. Now, our next thing on the list is something we've heard a lot right now, and that's social distancing. Now, social distancing is a public health safety intervention used to reduce the likelihood of transmitting a communicable disease. And what that does is minimize the exposure of infected individuals, or even just individuals in general. So not going to big venues, not gathering all together, not going into the workplace unless you're essential. That's what we've been hearing right now. Now, pandemic is something that we'll go over as well. That is just a global outbreak of disease. Pandemic and epidemic is something that a lot of the times are used interchangeably, but they do have slightly different definitions. Epidemic is an outbreak of a disease within a community or population, but I think it depends on who you are, whether you decide to use that interchangeably. What do you think?
So they're not interchangeable. So there's kind of like 3-ish levels we talk about. So there's endemic, which is when a disease is circulating constantly but at a lower level. So it's like year round. That would be something like Lyme disease in the US. And then there's epidemic, which is when there's a larger population over a geographical area that gets this disease over a shorter time period. So that's like how we have a flu season. And when it's a really bad year, we can have a flu epidemic in the US versus pandemic, which is when you have an epidemic occurring on multiple continents.
Okay, that makes more sense. Thank you for adding that. I know it can be very confusing, all those different words, unless you have a broad knowledge of it.
Yeah, so it's basically thinking of things on a local level, countrywide level, international level.
Okay. Now another definition that I added was coronavirus. Now, I have been having a hard time really kind of understanding what it is, especially with the media going all out and saying coronavirus is only specifically this one that we're experiencing now, or only referring to it as coronavirus. Isn't it like a group of viruses?
Yes, it's a huge group of viruses. Viruses are very diverse. It's like saying mammals, right? And then within mammals, there are like cats. But cats can be tigers, lions, panthers, your house cat. And so coronavirus would be like the group of cats where you have a wide range of them. Some of them do not cause the type of disease we're seeing now, while the current one as well as 2 previous ones have been very devastating to people as far as illness is concerned.
When you say 2 previous ones, which ones are you talking about?
There was the first one that we dealt with was SARS in 2003.
Okay.
And then a few years later we had MERS, which is Middle East Respiratory Syndrome.
Okay. All right. Are coronaviruses specifically respiratory in nature, or is it more than that?
Yes, all the ones that we've identified so far have been respiratory viruses.
Just as a tidbit, there are 7 known coronaviruses to infect humans. And so 4 of those just cause like your normal common cold. I've seen a bunch of number estimates for how many like colds it causes, but it's estimated about 20% of like common colds are caused by coronaviruses. So it's something we see, but we don't see it at this level of severity.
Okay. So that's what kind of makes it different from all of those. Right now, it's a different level.
Yes, and that's also because we see it in ourselves normally and not this severe. That's why we have vaccines for like other animals that are also susceptible to coronaviruses. Like I remember there was a trend of people talking about a bovine coronavirus vaccine and trying to use it on themselves, and it's different.
Wow, really?
Yes, it's different because it's not a human one, but we know about that one and we can vaccinate bovine for it.
Okay.
You have to think of, so viruses have to enter into a cell. And if you think of the cell as a door and it has a lock to it, a very specific key is needed to get into that lock. And so all of the viruses have their own key, and which allows them into very specific doors. And so you can make a vaccine against that key, but it might not be useful because the keys will be different for every virus.
I see. And of course, viruses change pretty quickly sometimes.
Yeah, some do. Some obviously more than others. Some of the viruses that we've been trying to make a vaccine for many years, like HIV, mutate at a rate that we're unable to nail down a vaccine for. Fortunately for us, this coronavirus is mutating at a slower rate, and so if a vaccine is made for it, it should last us for a long time.
All right, so I think we're going to move into the history part now. Thank you very much, Dr. Edwards and Miss Faith. So I didn't want to go into all the complete history of infections or viruses because that is quite broad, and I wouldn't be able to do that justice as I don't have a degree in that, or I'm not studying for that. So I'm just going to give a slight overview and then give what's happened with COVID-19 as of time of recording. Now, illnesses and infections have followed civilization as long as we can remember, as long as we've had records of it, all the way from the plague of Athens to the Black Death that most people find notable, and then the modern influenza, and what you mentioned, Dr. Edwards, SARS, which is severe acute respiratory syndrome. Now, our most recent outbreak was labeled COVID-19, and it began as an unknown pneumonia or large cases of pneumonia in China in December 2019. And the origins of the virus was widely disputed, a lot of people pointing fingers and not really exactly sure, but it has been linked to bats. Not really sure how it got out in the first place. We probably might not know for a very long time for sure. Now, the first case outside China was recorded in Thailand in June. I believe that was the 13th of June. And the first record of COVID-19 in the United States, I believe, was around the same time. And the WHO being the World Health Organization, officially named the novel coronavirus COVID-19 as of February 2020. Now, the symptoms may appear 2 to 14 days after exposure, and they include fever, cough, and trouble breathing. There are a few other things associated with that, but it's different for each person. And there are many ways to prevent or protect ourselves from this, but we're going to get into that once we get into the questions, which I think we're coming up on. Let's just break into it right away and ask a lot of people's questions right now. And that's, why do some people get sicker than others when they have the same infection?
All right, so there's a lot of factors at play when you get sick. And so with that, getting sick is pretty complicated. And so full case studies and an understanding of why this occurs with this disease is going to take a while since it's so new. We do know that there's something going on with the immune system when people get sick called a cytokine storm, which is when your body has an uncontrolled release of the pro-inflammatory molecules that your body makes to fight infections. So you just have such a robust inflammation response that it's overwhelming to the body. And severe COVID-19 has been correlated to a number of things, including like obesity and then pre-existing conditions such as high blood pressure or diabetes.
Now, I've heard a lot about smokers being at high risk. Is that true?
I read a study today that they weren't ready to say smoking on its own was conclusive, but that COPD, chronic obstructive pulmonary disease, which a lot of people develop as a result of smoking, is known to increase risk.
Right, and COPD will occur in areas where you have high air pollution, in addition to people who do smoke.
Yes.
Now, since we did talk a little bit about high-risk people, what are the groups considered high risk? Well, like you mentioned before, obesity and then COPD. Is there any more?
Yes, the elderly, and then like another pre-existing condition could be like various cardiovascular diseases. Like if you're already prone to heart attacks, you're going to have had some tissue damage to your circulatory system. And then those who are immunocompromised.
Okay, so what do people mean when they say immune compromised?
To be immunocompromised is to have a weakened immune system. This can also be from a number of things, such as people living with AIDS, or they're undergoing chemotherapy for treatment for something like cancer. I think most of us have a family or friend that has had cancer and needed treatment, so it's something that kind of everyone knows someone.
Right, so people who are immunocompromised are a lot more common than most people think about. So if you look at cancer treatments, just cancer treatments, it seems like everybody has a story of a family member or a friend who's been being treated. Like right now, I have an uncle in Florida who's being treated, and he was wanting to he lives in Florida, so he was wanting to come to Houston to get treatment, but now he can't leave his house to get treatment because he would be more at risk of acquiring an infection, let alone coronavirus infection, but any infection because of his immunocompromised state, which is why it's really important that we try to develop herd immunity and try to protect those that are at risk. Not everybody's at risk their whole life. Sometimes it's just a temporary window that somebody's immunocompromised.
Is that like being children? Are children immune compromised or at risk? I've heard that a lot.
Oh, yes. Yeah, so there are children who have cancer and have to have immunotherapy. You may also be hearing about how children have to develop an immune system. And so, not necessarily specific for this virus, but we do have to protect young children from other viruses. And so trying to use vaccines or herd immunity to protect them is critical.
Now, I want to go to a little bit of the science, which is what's the difference between a bacterial infection and a viral infection?
So bacteria are self-contained single-cell organisms that contain most of what they need to replicate, so to make like daughter cells. And most bacterial infections occur outside of a human cell. Something that's different with viruses is they don't have the machinery they need to replicate or make daughter viruses. So they have to infect a cell using that lock and key door idea, and they go inside of the cell and uses the cell's machinery to replicate. And whether a pathogen is inside or outside of a cell will cause a different immune response.
Okay, so say a bacterial infection can live outside the body, but like a virus can't, or?
That's absolutely correct.
Oh, okay. I didn't know that. Wow.
Yeah, it'll depend on the bacteria, but viruses are obligate parasites in a sense, and so they absolutely have to have a host to replicate. While bacteria, they're self-contained, and they may have require conditions that the body may have, like temperature or nutrients, things like that, but they can survive on their own. They have everything that they need to make another copy of themselves.
Okay.
It's like, you know how everyone goes swimming in like a lake and your parents say, put your head underwater because bacteria can go up your nose and then you can get sick.
Yes.
So bacteria can live in the water and keep growing, keep replicating. So you can start with like 10 bacteria, then 100, then 1,000. Viruses can't do that because they need to be inside of their host. So like if you have one virus in like the environment and its host not there, it will either break down because its host isn't there.
Okay, interesting. So, as far as treating each of those infections, I know it's pretty different, right?
Yes, it's very different. So for bacteria, you can use antibiotics, while with viruses, you will use antivirals. And an antibiotic is no good against a virus. So antibiotics are usually targeted against something that's special or specific about a bacteria. For example, it may be targeting the outer surface of the bacteria, while with antivirals, it'll instead target something special about the virus. So if you look at some of the antivirals we have against HIV, one of the neat things about HIV is it can do reverse transcription. And so its genome is made out of RNA, and then it has an enzyme that turns it to DNA, and then that DNA can integrate into our genome. And so we don't have that part. We don't have a reverse transcription part. And so that's a great drug to try to treat a virus without harming ourselves.
So I know when you go to the doctor and you're sick and you have a bacterial infection, can antibiotics be kind of a catch-all, or are there specific antibiotics like there would be for a virus?
So sometimes when you have a virus infection, especially like a respiratory one, you'll go to the doctor and they'll prescribe you antibiotics. And that's not to treat the virus, but rather to treat a secondary infection that might occur. So something we're seeing with COVID-19 is people get these respiratory infections due to the virus, but then they already have all this tissue damage in their lungs now, and they're extra susceptible to like a bacterial infection after that they could get sick from.
Such as a pneumonia.
Oh, I see. So you're saying that really it's not the virus necessarily that's harming individuals, it's what's caused after the virus? Or in combination?
It's a little bit of both. Yeah, it's a combination of both. So the virus will do some initial damage while it's replicating. This particular virus, every virus will have a different story of how it does things. But for this coronavirus, it'll infect cells in the lungs, and it'll cause a little bit of damage there. And then the immune response will come and try to try to take care of that infection. And when it does that, it's going to cause inflammation, and then we can end up with this cytokine storm where it's sending out messages for more immune cells, and then the whole thing starts to snowball. And it's that immune response that's causing even more damage to the lungs.
Now, we mentioned earlier a little bit about vaccines, and that can help as well. But a lot of people are afraid to get vaccines because of possible sickness they can get after it. Is that true? Can you get sick from a vaccine?
So for the vaccines that have been approved by the FDA, the vast number of people will be perfectly fine. Almost everybody will be fine. However, there are people who might have an allergy to one of the components of the vaccine. For example, you might have an egg allergy. There are a very small number of adverse reactions that can occur, and they can range anywhere from minor to severe. But as far as the risk is concerned, it's going to be very, very small.
Yeah, vaccines are extremely regulated, and they undergo very, very rigorous testing before they even make it to the FDA approval stage. And then once they're out of that, they're continued to be monitored.
Okay, so we should kind of have a bit of peace of mind when it comes to that.
Right.
Yes.
We'll go ahead and state here that there is no link between vaccines and autism.
Right.
So that's been a haunting thing for a while now, but there is absolutely no known link between vaccines and autism.
Right.
So whenever we see like adverse reactions, it's going to be things like a fever, maybe inflammation at the site. So those would be some of the minor symptoms that you would be seeing. But it'll depend on, as far as the more severe adverse conditions, it'll be dependent on the vaccine type that you took. So there's a whole wide spectrum of them. If you go to the CDC's website, and you want to look at the different vaccines, for example, if you want to know if you want to give your child the vaccine for chickenpox, there's these things called VIS sheets, VIS sheets, and you can download them for free, and they'll tell you all of the different adverse reactions that have been detected so far in people and what percentage of people have been affected by it.
All right. Thank you very much. And we'll also have some other sources listed down in the description for you guys too. All right, let's go on to the next question. Especially lately, we've been seeing in the news that people are possibly getting the coronavirus again, or the COVID-19 virus, excuse me. Can you get viruses more than once? Like, you can get bacterial infections more than once, right? So does that same apply?
You're right that you can get bacterial infections more than once, and viruses are a little bit more complicated on that front, though. So depending on the type of virus, yes, you can get them more than once. Viruses can have slight variations that change over time. So maybe you were immune to a type in like 1986, but it's mutated, and now in 2000 you're not immune.
For things like the cold viruses.
Yes. So many people experience this with like the cold. But then for other viruses like dengue, there's like 4 different types going around at once. So maybe you get type 1 and then you're immune to type 1, but now you're going to get type 2.
Well, for dengue virus, so that's an example where you're going to get infected by one variant and you'll get a little sick, but you can be infected by a second variant. And if that happens, it's actually way worse than if it had... It's way worse to be infected a second time with it, so you're going to have a worse illness and possibly even death. And then for SARS, it's way too early. SARS-2, the current one, it's too early to know.
Yeah. So what we saw with previous coronavirus, SARS-1, was that you did get lasting immunity after infection, but it's too early for us to know that about SARS-2 right now.
So there's a possibility.
There was a study done in monkeys, though.
Yes, the study in monkeys showed that the monkeys could not be infected a second time after infection. But we have yet to see that in humans. Yes.
Okay.
Yeah, so if it had a drastic change that allowed it to reinfect, yeah, you would have to consider that. There is a risk of a second wave, like we're in the first wave of this pandemic right now, and people are social distancing, but eventually that's going to end, the social distancing, and we'll all go back to the places that we normally went to. And depending on how many people were infected previously, we may not have enough herd immunity to prevent a second wave. And so there's a very good chance that it'll occur again, and once we all leave our homes, right? And so this could occur in July, August, September, whenever these measures are decreased on us.
So it's important to continue those safety measures and regulations after.
Yes, it's one of these things that had we all just went home for 2 months, it would have probably ended. But the reality is we can't all go home for 2 months. There's some critical jobs that need to be done. It's just not practical. So, I mean, it's been a very tough time. I know policymakers have been trying to do what's best, but you have one side that is commenting on health, on the health of the population. Then on the other side, you got to eat still, right? So you need money and economics of it. So you have two very important arguments at once.
Mm-hmm. Now, I want to go to how long viruses typically last. Like, I know plenty of people right now at this moment are wondering when it's going to be over. Do we have any kind of timeline for normal viruses, or?
Yes. So you have to remember that viruses are a very large, diverse group, and they have different aspects of them that make them different from each other. Some have an outer lipid surface like our cells do, some do not. So they have different shapes. Some of them are resistant to heat and acids and things like that. So there are some viruses such as parvovirus or rotavirus that can persist on a surface for many, many months, while there's others like rhinoviruses, the viruses that cause cold, or RSV that are less durable and can persist for only a few hours or even days on a surface. And as far as viral infections within your body, looking again at rhinoviruses, the cold viruses or flu viruses, these infections generally last for just a few days, while there's other infections, viral infections, that can last a person's whole life, like HIV or human papillomavirus, or even the viruses that can cause chickenpox or shingles. For SARS coronavirus 2, data indicates the virus is going to be durable for up to 72 hours on surfaces and maybe for 3 hours in the air. As far as within a person's body, it can last for at least 2 weeks, which is one of the reasons why the quarantine time is that long. Now, as far as how long this pandemic's going to be going for, nobody can really predict the future. It's been ongoing here in the U.S. for, we've been, I guess, isolated for about a month now, right? And if you look, we're starting to, so it's been a little while, and we're starting to see a little bit of the impact of social distancing, so it's kind of decreasing. But when you look at these curves, usually the amount of time it takes from start to the peak, you're going to see that amount of time on the other side of the curve, maybe a little bit less time. But then there's always the possibility of a second wave once we start to decrease these measures. So we can pretty much consider maybe another month or 6 weeks of this.
Okay. Yeah, I know at least as far as Texas goes, I'm pretty sure it's until May, but then who knows if we get a second wave, right? Now, I mentioned we were going to talk about precautions a little bit. So why are we taking so many precautions with the spread of COVID-19, and why is it so different from when we had influenza outbreak and the flu?
All right, so one of the really big differences between COVID-19 and influenza is that we don't have any approved drugs or vaccines for COVID-19. And then since it's brand new, we also don't have any immunity at all. But we do have those things a little bit for flu. So as such, for the flu, we have the means through just pharmaceuticals to limit the spread from person to person the best way we can. We don't have that with SARS coronavirus too, though, so the best thing we do have is social distancing. SARS coronaviruses also have a longer incubation period versus influenza viruses, and the virus is transmittable from person to person up to 2 days before symptoms even appear. Right,
so you can actually have the virus in you replicating and you don't even know. And if you're going about your day and I don't know, I interact as a professor with hundreds of people every day. And so I would have been at risk of infecting, hundreds of people. Then each of those people that I infected could go on, I don't know how, a football game or a basketball game, then they go there. And so a single person, before they even feel sick, could have infected hundreds, who then each of those can go on and infect hundreds. So it's you can see how something can get out of hand very quickly.
Mm-hmm. Does wearing a hospital mask, like a lot of people have been saying, also I believe the WHO recently, or the CDC recently suggested that everyone should be wearing masks outside. Does that help really at all?
You can probably set up a fight club for this one if you go online to look at the arguments on it. Yeah, a lot of people are in one camp or another camp. I will tell you what I do know, and we've seen videos of this, so evidence of it. So when a person exhales, and so you can look at temperature recording video, you can see how far somebody's breath can travel. And so if you put a mask on and do the same video, you can see that the air doesn't travel very far at all. And so if you are one of these asymptomatic carriers, so you have the virus, but you don't know it yet, you are containing it more to yourself. And so by wearing a mask, you are protecting those that are around you. So if you go to the grocery store and you don't know that you're infected, you're protecting everybody else in that store. And vice versa, when you go to the grocery store, and you look at, the hundreds of other people in there, you don't know if any of them are infected or not. But by wearing a mask, it's offering a little bit of protection of them from them to you. And so if we all wore masks, even if we didn't know, if we didn't know we had the virus or not, you should wear a mask to prevent the transfer of it. And if you do know you have the virus, you should probably stay home.
Now, do we need to be wearing gloves along with those masks?
Oh man. Okay, so I've been to the store a couple of times, and I think we need to probably have some TV commercials or PSAs about masks and about gloves. And so when I've seen people with gloves, we use them a lot. I mean, we work with viruses every day, so we use gloves and masks and coats and goggles and all of these things. And so we use them as a protective layer between us and the samples, but they're temporary. So if we think we get anything on our glove, we take our glove off and we put a new one on. And so if you want to wear a glove, if you feel like that's going to help you, you would wear it as a temporary measure. And so you would put it on before you interacted with the keypad at the grocery store where other people may have touched it. But once you're done interacting with those objects, you need to take your glove off. What I'm seeing people do that's incorrect is they're wearing a glove all day long, and they're still touching their face with it, right? So these gloves aren't killing the bacteria. They're just there just to change out. And so if you're touching a keypad with your gloves, then you keep your gloves on, you go out to your car, and then you drink, you grab a drink or something, or you grab some food or some gum with your gloves on, you're still
answer the phone or something.
Or answer the phone, you're still transferring the virus around or the pathogen around. And same with the mask. When I've seen people wear them in the store, they're constantly fiddling with it. And they're putting like their fingers and their thumbs on the underside of the mask. And all that's doing is trapping the pathogen there or bringing it closer to the face when they normally wouldn't have. So if you're wearing some sort of face protection, once it's on, leave it alone. Make sure it's nice and tight, but don't fiddle with it.
Right. Okay, so maybe we'll just stick with washing our hands then.
Yeah, so washing your hands often, and also keeping, some distance between you and another person is the best way of going about it. So if you are wearing a mask, the World Health Organization also says it works best if it's in combination with hand washing and social distancing.
So nothing is a catch-all. You really need to be doing multiple things to help.
That's correct. So the more that you do, the better you are with it. So if you're washing your hands, keeping your distance, leaving your home only when you need to. So it's like when you're out of milk and you have kids, well, okay, that's probably a time to go to the store. But don't be going out to the store 4 or 5 or 6 times a day. Mm-hmm. Don't be going out and socializing, things like that.
I'd like to add in a little bit too while we're talking about all the preventative measures.
Of course.
That as estimates and timelines change, because they're going to, it's not that experts overreacted, but rather the preventative measures we put in place based on their recommendations are working.
Of course, that is a very good point to make. I know a lot of people have been, well, once this is all over and it's not as big of a deal, but it could be a really big deal if these things weren't put into place.
Yeah, so similar to vaccines, they're a victim of their own success.
Now, I'm going to go on to our final question and just want to make sure, because there's a lot of information out there. Where would you suggest people go to find reliable, up-to-date information about COVID-19?
The CDC is probably the first source you should go to. Alternatively, you can go to the World Health Organization. So both of those are government-type websites. As far as more public access ones, I really enjoy the Johns Hopkins University website. So they were at it at the very beginning. They created the COVID-19 map that's been viewed millions of times. And so it's fairly accurate. It's been within a day.
Mm-hmm. And that one's cool because you can manipulate the map to zoom in by like county. And they'll tell you how many active cases you have in your county, how many recovered, how many deaths.
Wow. That's very nice. All right, I'll go ahead and I'll link that in the description, plus CDC and the World Health Organization website. All right, thank you guys so much for coming on. Thank you so much.
Thank you for having us.
Yes, thank you.
I want to extend a big thank you for Dr. Edwards and Miss Faith Cox. They also have a podcast I will link in the description below along with all those sources. Now, we went over a lot of information, and there are still plenty of questions and answers and material out there about different minority groups like immune-compromised people, disabled people, all of that. Now, if you'd like to learn more about our podcast and get updates on that, follow us on Facebook, Instagram, and Twitter. That's The Planet 100.7. That's the radio station we are based out of. Now, if you want more information about COVID-19, I have those links in the description below. Now join me next episode as we highlight Disability Awareness Month, with a show dedicated to service dogs. Until next time, be safe out there, folks, and take care.
This has been a Tarleton Radio Network podcast with production from AJ Heyer and Taylor Welch. Find more great shows by searching Tarleton Radio Network wherever you get your podcasts.